We'll end at 2, 2, all right, for the test that's on Tuesday. All right, so here we go. F of x is x to the 100th power. Find f prime of x. All right, so how do we do this? Right now, the only way we know to do this is to say f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h, right? That's how we do it. Use the definition of the derivative. Now this means I have to take the limit as h goes to 0. F of x plus h means plug x plus h into that. X plus h to the 100th power minus, what's f of x? X to the 100th power all over h. And you can check for yourself right now. If you let h go to 0, you're going to get 0 over 0, so we need to do some algebra. So what sort of algebra are we going to need to do? Yes? You could use the other definition. You're going to have the same problem. The algebra is going to be a nightmare. This algebra is a nightmare, unless anybody feels like expanding x plus h to the 100th power, right? Okay, so I want you to go back to something we talked about a long time ago in this class. Remember Pascal's triangle? Do you remember we did that? Okay, so if you look back in your notes, if someone could look back, did I do x plus y or did I do x plus h? I did x plus h. So look back in your notes. I showed you that x plus h to the 0th power was 1. X plus h to the first power was x plus h. X plus h to the second power was x squared plus 2xh plus h squared. And we started to come down here, and we got to the very end, and we said, what would x plus h to the n be? Do you remember that thing there? I do have that in the notes, right? And someone looked, the last one I did, I think, was this one. And what we said was, what this would look like would be x to the n plus, does someone have it written down? No? Who has it written? I just want to see. No?
We don't have the n version.
You don't have the n. What was the last one I had?
It was the 6.
6th power. Okay. So I said this was 6, and then this was x to the 6th. Do y'all remember the pattern? We had some number here, right? And then x to the 5th, h. And then plus some number, and then x to the 4th. Oh, that's not a 4. H squared, and then plus dot, dot, dot. And we went all the way down to the end. It was h to the 6th, right? Okay, and what was the number in front here? We did figure out what it was. It was a 6. Okay, look at the line above this one in your notes. It was x plus h to the 5th. And that was x to the 5th plus what was the number right there? It was 5. And then x to the 4th h plus blah, 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 right? And then what was the one before that? X plus h to the 4th was x to the 4th plus what? 4 x cubed h plus blah, 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 right? So there's a pattern in this. If you look back at this Pascal's triangle that we did, there's a pattern in the first 2 terms of every one of these. The first 2 terms follow a pattern. The pattern is that the power on the x will be the power on the binomial here, right? Plus the number in front here is also the power here, right? And then we have the power will come down on x and the power on h starts coming up. Agreed? Okay. So when we're back here looking at this to the 100th power, right? We know that this right here is going to be difficult for us to do. Like, we don't want to have to go through this, do we? So what we kind of did at this point, we as in humans, mathematicians, we said, is there a way that I can come up with a general formula for taking the derivative of this if this right here is any power n? So if it's x squared, do I have a way of getting to the answer easily? If it's x to the 7th, can I get to the answer easily? So what we did is we said, look, this sucks. Let's start this over, and let's just say, can we deal with n power? All right? So what would change if we set up this derivative? We do this, what changes here? This would just be n, right? And this would be n. But following this off Pascal's triangle, x plus h to the n, what would the first term be? X to the n. Plus, what would the next term be? N, right, which is the power like the 6. X to what power? N minus 1. So whatever this n was, right, if it's 6, over here it'll be 5. If it's n, over here this will be n minus 1. What's the next thing next to this? We have an h. And then plus, well, the rest of it's going to be like a bunch of stuff, right? But there's something important about the rest of it. I'm going to have an x to a power, right? What about the h? H squared. Okay? And then plus some number, and then x to a power, who cares, then h cubed, right? Then plus all the way down to h to the n power. That's what will happen if I expand this. So, do you see the x to the n in front? And do you see that we have a minus x to the n in the back here? We're going to put this together now. All right, we're going to rewrite this limit as this expanded using that. So that's x to the n plus n x to the n minus 1h plus something in front of x to some power h squared plus, and then all of this stuff until I get down to h to the n. Do y'all agree that that's kind of like my very loose expansion of this? And now what's still after that? Minus x to the n. Then all of this over h. Now, even though it doesn't look like it's going to be that good, we do get these to cancel, don't we? Okay. If those cancel, what can you tell me about everything that's left in the numerator? They all have an h, don't they? This has how many h's in it? This has how many h's? Next one? 4, 5, 6, 7, all the way to the n, right? So I do have an h in every single one of them. So I can pull at least one h out. So let's pull one h out. If I pull one h out of the top, if I factor out an h, then what's left here? N x to the n minus 1, right? Because the h came out. Plus, next one, some number. I don't even care about that number. I'll still have the x to some power, right? How many h's will be there? 1, right? Because I pulled one out. What can you tell me about the next piece? It'll be something with something. Will it have an h in it? So this next piece does have an h. Actually, it would be an h squared, right? What can you tell me about the next piece? It's going to have some stuff in it, right? And it also has an h cubed in it. And I go all the way down to the end. And at the very last one, do I still have an h there? Yeah, because it was h to the n, right? So I pulled one of those h's out. So I should have h to the n minus 1. Now all of that is going to be divided by h. And those h's cancel. Do y'all see what's about to happen? Let h go to 0 now. If h goes to 0, is this impacted at all? No. Is this one? That has an h in it. It's gone. Does this have an h in it? Gone. This one? Gone. 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 Everything's gone. The only thing left is that right there, right? That's the only thing left. And so because that's the only thing left, that's our answer. And is that a formula? Yes. The formula is, if you're ever trying to take the derivative, right? If you ever want to know what the derivative of x to the n is. So if someone starts with a function, f of x equals x to the n, and you want to know what the derivative is, well, guess what it is? It's that, n x to the n minus 1. Don't ever have to do any work anymore. You don't have to do any limit anymore. That's a formula. And this is known as the power rule for differentiation. So let's see the power rule in action. Let's go back to the problem that we started with, that we kind of were like, we do not want to do that. That's going to suck, right? So now you're given the function f of x equals x to the 100th power. What is the derivative of that according to the power rule? 100x raised to the 99. So essentially what happens in this formula is whatever the power is actually winds up being the number in front, right? And then the power just comes down by 1. So I'm just going to take this 100, pull it out front, 100, x to the 99, and I'm done. That's a heck of a shortcut, isn't it? So you can use, because now, so on the test, if I ask you to find the derivative of a function, right? I'm going to tell you to use the limit definition. And that means you have to use the limit. These shortcuts are not on the table for you to use unless I don't specify how to take the derivative. Let me say that again. On the test, I will ask you to find the derivative of a function, or I will ask you to find the tangent, slope of the tangent line. And I will say using the limit definition. So this first test that you're going to take, I want to see you using limits. From here on out, after this test, you will get to use all the formulas. All right? And that's our first one. That's the first formula. Section 2.3 is called basic differentiation formulas. So that's our first one. Let's see it in action again. Let's say we have the function f of x equals the square root of x. Find f prime of x. Find the derivative. Okay, so this is x to what power? This is x to the half. X to the half, right? That's what that really is. So can we use the power rule? Yeah, because we have the power, right? The power is 1/2. So the derivative of this, all we're going to do is pull the 1/2 out. And then do what to the 1/2? Subtract 1. So I'm going to take 1/2 and subtract 1. What's 1/2 take away 1? Negative 1/2. So we have 1/2 x to the negative 1/2. And that is correct. That is a correct answer. However, what's another way I could write that? I could bring that 1/2, negative 1/2 down, right, like this. And then that really means the square root. So that's the same thing. I would like for all of you to burn this into your brains, because this one comes up so much, that the derivative of the square root of x is 1/2 square root of x. I agree, this is correct also. You could say 1/2 x to the negative 1/2, but I think you should learn it this way. The derivative of the square root of x is 1/2 square roots of x. What about the cube root of x? Yeah, so let's see. Cube root of x, what's the derivative of that? So what's the power on this? 1/3? Okay, so let's use the power rule. 1/3 comes out. X to the 1/3 take away 1, right? Which is negative 2/3. And then we could drop that down, couldn't we? And raising something to the 2/3 is the same as taking the cube root of it squared. Now this one you don't need to memorize because this one doesn't come up as much as that one. That one you should memorize. This one you should just make sure you can do the mechanics. Is it making sense or not? All right, let's do this one. You'll recognize this one, I think. Do you recognize that? We started class with that, didn't we? That's the problem we started class with. We said, hey, let's find the derivative of this. So let's do it again. But now, I'd like for us to use the power rule if we can. So can you look at that as x to a power? So you have to first write it as x to a power. This is the same as x to what power? -2. Okay, that's what you need to work off of, that right there. So from that, n is what? -2. So let's use the rule. The -2 comes out. X to the -2 minus 1. -2 minus 1 is -3. -2, x to the -3. And isn't that the same as -2 over x cubed? And isn't that what took us about 15 minutes to do earlier? Right? Isn't that the same answer? Okay. Isn't this better? All right. So this is where we're headed. We're headed to, look, if we want to take derivatives in this class, the limit, yes, is the ultimate definition of the derivative. But if we can find formulas for certain things that we run into a lot, we want to use them. And this is the first formula we have, the power rule. Let's see if we can't come up with a formula for something else. And this will be our last thing, and we'll talk about the test. I'm sure you've always wondered what the derivative of sine of x is. Now, we don't have a rule for this yet, right? I really do hope you can appreciate how profound the formula we just got is. The x to the n, we have a formula for that now. Okay, we will carry that with us for the rest of our mathematical lives. The power rule is always here for us. Now we'd like to know, is there a way we can figure out what the derivative of sine of x is? We don't have a rule yet, right? So mathematicians looked at this, said, can we figure out what the derivative of this is? Well, where do we start? With the definition, right? The limit definition. This is the limit as h goes to 0 of, what's f of x plus h? So we plug x plus h into the function. Sine of x plus h minus sine of x all over h. And now you get to try and figure out what that is. You sit there and you look at it for a while and you realize you don't know what to do. All right? You sit there and you go, well, this right here is not this, right? Please, no, don't do that. This does not distribute through like that. This is not a number. You can't do this. So that's no good. So there's nothing, it appears there's nothing algebraically we can do. But you took pre-cal, right? And there is a formula when you have sine of two things added together. Do you remember what that formula was? So this is called the sum and difference formula for sine. So this should turn into, so it's on your formula sheets. In case you don't have it here, it's in your formula sheets. What reference page, just so everyone knows? I know you all have those with you, right? Bring them with you every day. I don't have mine. Page 2? Okay, so what do they use there? They use x and y, or they use x and y? Here we have x and h. So it's going to be what? Sine x, cosine h. So sine x, cosine h, plus cosine x, sine h. Okay, that is this written using the formula from pre-cal. Now what do we still have up here? Minus sine x all over h. Okay, did that help at all? Does anything cancel? No, nothing cancels. Do y'all see that? Nothing cancels? Nothing cancels. So even though it looks like that helped, it doesn't really look like it's going to do much. However, look at this. This is equal to the limit as h goes to 0. So watch, I'm going to be a little bit clever here. I'm not sure if clever is the word, but sine x cosine h minus sine x all over h plus cosine x sine h all over h. All right, is that the same thing? So what did I do? I kind of rearranged the numerator, didn't I? I moved this minus sine x over here, and I split it into two fractions, which I'm completely allowed to do because they have the same denominator, right? If you put these back together, you get this. Okay, so that's legal. Now, out of these first two, or out of this fraction in the numerator, what do they both have in common? Sine x, don't they? So this is the same as limit h goes to 0, okay? I'm going to factor a sine x out of there. Sine x comes out. What am I left with when I pull a sine x out of the top? Cosine h minus what? 1. Now this is all still over h, right? But I'm going to write it like that. Isn't that the same? It's like I just pulled the sine x out, pulled it out front, and wrote whatever was left over the h there. Okay? And I still have that over there, right? Now watch, I'm going to write this one this way. If you're sitting there going, I have no idea how I would ever have come up with this on my own, this is not what it's about. It's about me showing you this, and then you get to use it, all right? But I'm not going to hand you it, not going to hand you the tool unless I show you where it came from first, all right? Yes?
Well, I don't know if it's a step ahead, but I was wondering if, since h is going to 0,
Uh-huh.
be able to do cosine of h minus 1 over h, wouldn't that equal 1, or does that feel?
You're close. You're close. You're recognizing what I was hoping you'd recognize. And that is the limit as h goes to 0, right? Has no impact on that. Why? Because it's sine x, not sine h, right? Does it have any impact on this? No. It only affects the things with the h's in it. And hopefully that kind of rings a bell. That was one of the two important formulas I said you should remember. That goes to what? That goes to 0. Okay? So when I take this limit, this is going to go to sine x times, and this is going to go to 0, plus this is cosine x, and what does that one go to? 1. That's sine of junk over junk. The junk matches. The junk goes to 0. So what's your answer? Sine x times 0, which means it goes away, right? Plus just cosine x. So what's the answer? Cosine x. What? Cosine of x? You mean to tell me the derivative of sine of x is cosine x? That's exactly what I'm telling you. Now let's try and convince ourselves of this visually. If I ask you right now to graph sine, everyone would go like this, right? Of course you would, right? That's the sine function. Now, like we did in the beginning of class, let's try graphing its derivative. And I'll start with the easy points. If I go right there, what's the slope of the tangent line there? 0, so I should put a 0 there, right? What about here at this point? What's the slope of the tangent line here? 0, okay. About right, I don't know, right about there, What's the slope of the tangent line there? It looks like it's positive, right? Looks like it's about 1. Well, it actually is 1. What's the slope of the tangent line, like right about there? It's not as steep as this, right? But it is still positive. So what happens is you're going to connect between here and here. Your slope is positive but flattening out to 0.
Yeah.
Okay? And then what happens when you get in this little region right here, from here to here? It's going to be negative, 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 and then like -1 maybe? And then it's going to start getting, it's still negative, but it's going to start to flatten out to 0. So it's supposed to be like negative, 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 like to -1, and then start flattening back out to 0. And then it does this on the other side. And what is that graph? Cosine x. So the derivative of sine of x is cosine x. Let's try it the other way around. Is the derivative of cosine x sine x? So we would have to go through this whole thing again, right? Well, let's just try and convince ourselves yes or no real quick. I'm going to grab cosine x right now. Cosine x looks like this. 2 pi, pi, right, like that. Okay, so wow, that's really not good. Okay, there. So let's get the easy points first. What's the slope of the tangent line right here? 0, so there. What's the slope of the tangent line here? 0, so I should have a 0 there. Slope of tangent line here? 0, so I should, so I should have that, right? Slope of tangent line. So remember, what does sine look like? Sine goes like that, like this, right? It's looking pretty good, looking pretty good. But what's happening here? Like, if I just go to here, what's the slope of that tangent line? Positive or negative? Negative. It's negative, which means I'd have to put a point down here. And then if I go over here, it's going to be a little steeper. And so if you do this, it's going to wind up looking like this. I'm not going to go through the whole thing, but get that. And is that sine? That's not sine x, but guess what it is? It's negative sine of x. It's sine of x flipped over. So here's what we have. Because I want to stop and talk about the test, and I'm so exhausted right now. I was just sitting here a second ago writing this down. I couldn't even remember if I was in Cal 1 or 2 right now. I was like, okay, I'm losing it. So from 2.3 today, so far, okay, so far from 2.3, here's what we have. If you have x to the n, right, and you take its derivative, I'm going to write it this way. If you were to take that and take its derivative, what would the answer be? Nx to the n minus 1. That's our first formula, and we love it. Okay, the next thing we have is that if you take the derivative of sine of x, we prove this one using the limit, that the answer is cosine x. And now this, cosine x, take the derivative of that, and I'm telling you it's negative sine x. Now this one right here, I didn't prove it to you. I just tried to visually prove it to you. To do the actual proof of that, you would have to do limit h goes to 0, cosine x plus h minus cosine x all over h, and then guess what you would do? Same thing, expand that out, group things up, and it would all work out, all right? So we've got 3 things so far. What's coming down the pike still? What's the derivative of tangent? What's the derivative of secant? What's the derivative of cosecant? What's the derivative of cotangent, right? And we have conveniently avoided any functions that have products in them. Like we have not, like what's the derivative of x times sine x? Like we have not talked about what happens if you multiply 2 functions. Like could you take the derivative of that? Yeah, that's x to a power, right? Can you take the derivative of that by itself? Sure, that's sine x, derivative is cosine x. But what happens when you multiply them together? Can you just take the derivative of each one? And the answer is no. And that's that's bad news. That's bad news. Because that's what makes this class hard, and it's what makes Cal 2 hard, all right? The test. We have 10 minutes, right? The test is on Tuesday, right? And it will cover up through 2.2. You are going to study your homework. And you're going to study problems that I've done in class. Right, so what I'm going to do is I'm going to sit down, I'm going to look at your homework sheet and the quizzes I've given you, right? I'm going to sit there, I'm going to look through your homework assignments, look through the book, and I'm going to start putting a test together based upon those problems, all right? Now I'm not going to give you the exact problems, but they will be very similar. So if you've been doing your homework, you know that there are problems in here that I have not discussed. They're all still fair game to the test. So I think you kind of know in terms of what I'm going to draw from, the problems. I think the biggest thing is how are you going to prepare? Like how are you going to study? My recommendation is that you find a friend, have them go to section 1.2 or 1.5, whatever. Pick a problem here. Have them pick them for a set of 10 problems or so, and tell you to do them. And you sit there, and you start a clock, and you sit there with your formula sheets, and you see if you can do those 10 problems in an hour and 40 minutes or whatever it takes. In other words, practice the testing environment. Sitting there going and watching my homework videos and being like, yeah, I can do all that, or I already did the homework, I'm good. I think that's not a good way to study. A good way to study is to practice as best you can, practice the pressure of the time and all that stuff, right? So it's problem recognition. You walk in, you look at the problem, you know what to do. If you're going to spend 10 minutes trying to figure out what to do, there's no way you'll finish the test. In terms of the length of the exam, let me pull up an old one, although we're not going to look at it. Just to give you an idea of some exams that I've given in the past. In terms of length. For this exam, you can use your formulas, right? Yes? What are some formulas that you think you'll need? Like, you need to know y minus y1 equals m times x minus x1, right? You need to know the point slope formula. Are there any questions while I'm bringing this up?
Can you use the reference sheet right on the test?
Can you use what?
The reference sheet.
What reference sheet? The formulas from Canvas? Yes, that's what you're allowed to bring.
Okay.
Yep. Now you are not allowed to use that handout I gave you with the summary of the limits. That, where it's like fixed over 0, fixed over, that you are not allowed to use. I told you that when I handed it to you, to get acquainted with it, but memorize it. Okay, here we go. Let's see, this is an old spring 18 exam. Just give you some idea of what I asked. I gave them a graph, a picture of a function, and asked them for limits from the left, from the right. Does the limit exist? What's the function's value there? Very much like a quiz I gave you in the very beginning. Why is that not changing? Then I asked them to sketch me a function that had certain conditions. So I said, draw me a function where the limit as x approaches 2 from the left is 4, limit as x approaches 2 from the right is 5, and f of 2 is 10 or something. So again, you had problems like that in your homework where they gave you conditions, you drew the picture. I'm not saying this is your test, I'm just giving you a feel for what I've asked in the past. Then I asked them to evaluate some limits. So like the first limit I gave them was one of those ones where when you plug in the number, nothing bad happens. Like you get like 2 over 3. And so your answer is 2 over 3. But then people will go try and factor it and do all this crazy stuff with it and they'll waste time. Don't be that person. And then I gave them a limit that you got 0 over 0 and it required some factoring. Then I gave them another limit with 0 over 0 that required a different kind of factoring. Then I gave him another limit that gave him 0 over 0, which required a different sort of technique, right? So what sort of techniques do we have? We have factoring, we have what were some of the algebra things that we did? Conjugate, right? Combining, getting common denominators, right? Yep. So, oh, and then the one that everyone loves. The one with that trig stuff in it, where you have to like make something appear, slide it over to make it like sine of junk over junk, and then, remember those with the boat with the hole, and you plug the hole in the hole, you get leaks somewhere else? I love those problems. I can promise you that. That will be in there, okay? Okay, so this was one. Do you remember a problem in class where this had to do with continuity, where we had a piecewise function and we had to find the a and the b that made the functions come together and be continuous? Yeah. I put one like that in here. But it only had one unknown. So they only had to solve for one variable. So I think there's a problem in your homework that's like that, where it only has one variable. Is there a question?
No, I was saying that we also did one where we solved for 2 as well.
Yeah, so that's continuity. That's the question on continuity. Okay, this limit right here, you get fixed over 0. So I gave him a problem so I'm on number 9 right now, okay, for this test. You got fixed over 0. So how do we do that when you get fixed over 0? You do like a number line, you do like left and right, and you figure out, the answer is either infinity or negative infinity, so you figure out which one it is.
Is it going to be a sine or a cosine? Is it going to be a trig fixed over 0 kind of a thing?
It could be. It wasn't in this test, but it could be, because I gave you a quiz like that.
Right.
I gave you a quiz with a trig in the sine in the bottom, right? Okay, here's a limit where you got infinity over infinity. So that was one where you had to like multiply through by something, the highest power of the denominator, to get it to,
Oh yeah, to get everything below.
yeah, to get everything to go away except for, so infinity over infinity. Let me see what else. We're on number 10. Now number 11. This one was infinity over infinity, but the bottom was a square root. So I'd shown you on those problems that if you have a square root, you have to like force something into the root, and it gets squared on the way in. I like those problems. There's one here. Here's one, infinity minus infinity. So you have to factor, try and factor. And we did one problem. I did one that was fairly easy, and then we did one where like they had weird roots and we had to get common denominators.
Professor, even
Yes.
kind of like definition problem.
This is more mechanical stuff. It's not going to be like, what is, continuity? It's not going to be that. It's going to, okay, and then here we go, number 13. Find the equation of the line which is tangent to this function at this point. So you've got to use the limit definition. Which one you use is up to you, all right? So that's really tied into like last class. And then the last problem, number 14, was another find the equation of the tangent line. Okay? So for this, we got through 2.2. So the things from 2.2 that you might see would be where I draw a function and ask you to draw its derivative. And like I said, the homework for this section, you'll get some practice with that. Other than that, yeah, just look at your homework.
You mean like
Pardon me?
eyeball it?
Yeah, so whenever I give you a function and ask you to draw its derivative, it's always going to be kind of eyeballing things. As long as it follows the basic pattern of what's supposed to happen, you'll be all right. Okay, any other questions about it? Yes. Are there usually only 15? It depends, because the problems change as we proceed through the course. So, 15, I think. This is 14 problems. The next one may be longer or short. I'll have to look. I wouldn't always count on that many. I go more based on time. So what I do is I make the test, I take the test, I see how long it took me. I usually multiply that by 5 or 6, and I need to keep that within 100 minutes. So my expectation is that like what I can do in 20 minutes, you should be able to do in 100 minutes, because I'm making the problems, right? So I should know how they're going to be worked. Yeah. Any other questions or comments? Yes?
Is there a practice test online, like one of your old ones?
There's not, I don't have like a review for you to go do. There might be some old tests online. There might be a folder. Has anyone looked in our old, is there some old exams? I mean, you can go take a look at those. There's no guarantee. So the idea is this. I'm just trying to prepare you all for, as you move forward in your math careers or engineering, that you're not always going to be handed a review for a test. Like, you got to learn how to study properly. So we want to try and build that skill up here. See how it goes. First test, right? We'll see how it goes. Promise you no surprises, though. I'm not going to throw something that's like, what? We never talked about this. So if you see the problem and you're thinking, what? We never did this. That's because you haven't reviewed enough yet. All right? Okay. Have a good weekend. I'll see you Tuesday. So done. Let me turn the camera off. Yeah, I already collected it, so you can just put it up there.